Hey everyone, today we are solving this problem number C, Make It Beautiful from Codeforces round 1030, division 2. In this problem, we are given an array A of n integers and we have defined a term beauty. And beauty for a number x is the number of set bits in the binary representation of x. And the beauty of an array is defined as sum of beauties of all the numbers in that array. And in one operation we can increase ai by 1, and we are allowed to make at most k operations, and in those at most k operations we have to maximize the beauty of the whole array. So how can we do this? This is the first test case. So here okay, so here n equals to 5 and k equals to 2. So k equals 2 means we can do at most 2 operations. So, and this is my array A, and I will see the binary representation of all the elements of array A. Okay, currently how many set bits in the first element? It is 0. There is no set bits. In the second number there is only one set bit, and in the third element there is 3 set bits, and here it is 1, and here the number of set bits is 1. So what will be the beauty of this first number? It will be 0, and for this beauty is 1, for this beauty is 3. If I talk about the beauty of this array A, beauty of array A will be sum of all these beauties. Okay, 0 plus 1 plus 3 plus 1 plus 1. Okay, and what is this actually? Actually, beauty of an array A is nothing other than the number of total set bits in that array A. Okay, so and here we have to maximize the beauty of whole array A. So how can we do that? So how we have to use these at most k operations so that we can maximize the beauty, or in other words how can we maximize the number of set bits in the whole array? So we have to do addition to make more set bits. So let's say there is a number 5, and in this 5 the binary representation of it is 101, and okay, for 101 what is the contribution of every bit in the number 5? For the 0th bit, that is this first bit, the contribution is 2 power 0, and this the first this bit at the first place, its contribution is 2 power 1, and for this bit the contribution is 2 power 2. But since here the bit is 0, this 2 power 1 is not there. If you will add 2 power 0 plus 2 power 2, it will be equals to 5. So that means if I, in this binary representation 101, if I want to make this 0 bit as set, so what I have to do, since in the contribution of every bits there is no 2 power n 1, so if I make this bit 0 as 1, if I make it as 1, that means I am adding 2 power 1 to this number 5. Okay, because the contribution of this place is 2 power 1, and earlier that was 0, but now if I am inserting a set bit at there, that means I am adding this 2 power 1. Okay, so let's say there is a binary representation 11001. If I want to insert a set bit here, so first I have to see at what place this bit is. So this is 0 place, this is first place, this is second place, this is third, this is fourth. Okay, if I am trying to insert set bit here, that means I have to see the contribution of this place, that is 2 power 1, and actually I have to add this number 2 power 1 to this number if I want to make this first place bit as set. If I want to add set bit at this place, this second place, then I have to add 2 power 2. So if I add both 2 power 1 and 2 power 2 to this number, then what will happen? This number will change to which? It will change to 1 1, and at these both places there will be 1. Okay, so now we have to do this thing greedily. Okay, so if I ask you, for all the places, this 0 place, 1 place, 2 place, for all the places, which place will take the minimum operations, or which place will take the minimum thing to add, I think that is to this 0th place. What it will take, how much cost it will take? It will take 2 power 0. How much cost this one place will take? It will take 2 power 1. How much cost this second place will take? It will take 2 power 2. If we want to make set bit at that place. So we can do this question very easily. If we traverse on all the bits from let's say this is a long number, then there will be total at most 64 bits, at most 64 bits in a number. So we can traverse all the bits from 0 to 63 for all the array elements. And first we will go to this 0th place, and whenever we will see there is a 0, then we will make it set. How? By adding 2 power 0. Here also there is a 0, then we will take a contribution of 2 power 0. Okay, and then we will go to first place. Then we will see here it is 0, we will contribute 2 power 1. Then again there is no 0 in this row, so then we will go to the second place. So in this manner we will go to every place. Whenever we will see there is a 0, then we will make it set bit by adding the contribution of that bit. So, and in this manner, in this greedy manner, we will use this at most k operations. So now this is the implementation of this code. So here first I have made a function, this count once, which will give me the number of sets in any number x. So first we are taking this input integer n and k, where n is the length of array A and k is the at most operations we can do. Then I'm taking input this array A, and this is a boolean done. I am making it so that when I have done the problem, I can do this done as true and break this loop as earliest. Otherwise we have to traverse to all the bits from 0 to 63, because if we have used all the k, if we used all the at most k operations, then I will break the loop and I will use this boolean to do that thing. So initially my beauty is 0, and first for calculating the initial beauty, I will traverse on all the array elements and take the number of set bits in every element and store it in it beauty. Now beauty is currently storing the current or you can say initial beauty of the array. Okay, and I have to maximize this thing. So now I will traverse on all the places from place 0 to place 63. Okay, and for all the places I will see all the array elements. For let's say first elements, that is AI. For all the AI, I will extract that bit at that place by doing this AI and one left shift that place. This will give the bit at the place, at that place in AI. So if that bit is 0, then for the cost for that bit will be one left shift place. Okay, this one left shift place is nothing, just 2 power place. I can do this like this. Okay, one left shift place is nothing other than 2 power place. Okay, so for any place, either if it is first 1 place or 2 place, then for 1 place the contribution is 2 power 1. Okay, for second place the contribution 2 power 2. So that will be cost for that place, and we will subtract it from the k because we are using it from k, and we will increment the beauty. Okay, and if we will go in this else condition, when my k is not sufficient to do more operation, then I will make this boolean done equals to true, because I have now done the problem. Now I can break. I will break from this. This break will take me out from the inner loop, but for the outer loop I have to again break. So for that thing, actually I am using this boolean done, and at the end I will just print the beauty of the total array. So that was our approach to solve this problem. If you have any doubts or questions, feel free to drop them in the comments. I will be happy to help. So thanks a lot for watching. Don't forget to like the video if you found it helpful, and subscribe for more competitive programming content. See you in the next video.